Today we will read about pH and its various acid-base balance fundamentals of electrolytes. Basically, today we'll start with the introduction part, that is what is pH. So pH is nothing but a scale where it is used to specify how the acidic and how the basic solution is. Generally, acidic solution, we know a little bit, acidic solution have a lower pH while a basic solution have a higher pH. At room temperature, pure water is neither acidic nor basic. So their pH is 7. So pH is generally, if you can tell the definition, we can tell that this is a concentration of hydrogen ion in a solution, in a water-based solution. So basically, we will deal with the hydrogen ion concentration. So pH scale correspond to the concentration of various hydrogen ions. For example, pure water molecule H plus ion, that is a hydrogen ion concentration, is 1 to the power 7 molar. Therefore, pH would be 7. So here we can see this is a scale. Here we can see this is a scale where pH 1, pH 2, pH 3, pH 4, 5, 6, like this the scale has tabulated here. So in 7 it is a neutral pH. Below 7 we can tell this is a strong acid, right? That is a 1, 2, 3, 4, 5, 6, and after 7 means when the pH is more than 7, then we can tell the solution is a basic solution. So acidic solution and alkali solution, it is a universal indicator. Different color coding is there. Generally we can code like this. If you are using pH strip also in lab, we will code like this. So next is the acid. Acid means any type of compound which forms H plus ion in solution. That is a proton donor. That is an acid. And case of base, any compound which combines with H plus in solution. That is a proton acceptor. So here we can see that the carbonic acid releases H plus ion, whereas simultaneously the bicarbonate accept that H plus ion, so it is a base. Next, this is a measurement. How we will measure the pH? Generally, we can measure the pH by 3-4 major steps are there, and 3-4 instruments, 3-4 procedures are there. Generally, pH strips are there, pH indicators are there, and pH meters are there. So pH meter already we have studied in our first semester session. pH indicators are there and pH strips are there. So some important indicators in a clinical biochemistry laboratory. These are few indicators, name of few indicators which is used in our biological laboratory. First of all, that is a phenolphthalein. Phenolphthalein, here the pH range is 9.3 to 10.5. So here the color in acidic medium, it will show colorless, but in case of basic solution, it will show the pink color. That is an indicator. Simultaneously methylorine, it will work within the pH range 3.1 to 4.6. So color in acidic pH, that is a red, and in basic pH, that is yellow. One more is there, that is bromophenol blue. This is also an indicator. This will work in acidic pH, right? The pH range is 3 to 4.6. This is quite acidic. So in acidic pH, it will show the color yellow. In basic pH, it will show the color blue. Simultaneously, few others are there, that is a methylate, phenol red, and the litmus. We know the litmus paper already. We have carried out this experiment in our 12th class. That is a litmus paper. The pH range of the litmus paper is 4.5 to 8.3. The color in acidic solution, acidic pH, it is a red color, and when it will go to the basic solution, it will show blue color. So some buffer solution is there. So two types of buffer solution are there. One is acidic buffer and one is basic buffer. So in case of acidic buffer, that means solution is a mixture of weak acid and a salt of this weak acid with a strong base. Suppose acetic acid, CH3COA, it is a weak acid, and its salt, that is a sodium acetate, that is a CH3COONA. This is an acidic buffer because it contains the solution of a mixture of weak acid and the salt of this weak acid with a strong base, right? And the basic buffer is what? The solution of a mixture of weak base. Weak base is ammonium hydroxide, it is a weak base, and salt, that is the ammonium chloride. Ammonium chloride, this is a weak base a salt. That means that ammonium chloride plus ammonium hydroxide. This is a combination of basic buffer. So in future we will learn lots of other buffers also. So this is the equation. Based on that, we will calculate. We can calculate the pH. That is a Henderson-Hilbert equation. Who wrote the equation in 1908. So basically, the equation is nothing but a calculation of the pH, where we can tell that if we will take a HA solution, and if it is dissociating, it will form H plus and A minus. So if I'm taking the Ka, that is the activity constant, that is Ka, or the dissociation constant is Ka. So dissociation constant, we can tell that this is a hydrogen ion, concentration of hydrogen ion here we can tell, and the A minus, that is a basic, that is A minus, a basic part, and concentration of H plus and concentration of A minus, if we're multiplying this and dividing by the whole concentration of HA, so from there we will get the Ka, that is a constant value. So this is a Ka part, right? So here if you're taking the logarithm of both, so log Ka is equal to log H plus minus log A minus by HA, because if it is minus, then minus log Ka equal to minus log H plus, just minus log A minus by Aj. So pKa value, that means equal to pH. So pH equal to minus log concentration of H plus pH. This is a pH value. This one is a pH value, and minus log A minus concentration of A minus divided by concentration of H, the whole thing. So here, if you can elaborate the equation, we can tell that pK equal to log of proton acceptor by proton donor. So this is a basic equation scheme of the Henderson-Hilbert equation. Now we will we will focus on the buffering system in our blood fluid. So many buffering systems are there, because based on that only our hormones are regulating, our different electrolytes are regulating in our body. So for that we need to first we need to understand little bit about the concentration of various ions and the blood pH of the blood. Generally blood is a buffer solution. So why we can tell that blood is a buffer? Because blood is working in a three buffering system. Blood contains three buffering system. So that part we will learn in the next session. Thank you.